Okay, ladies and gentlemen, what this next example is trying to show you, it's trying to help you understanding a connection between solving an equation and a graphical interpretation. But let's take what we basically know. This equation, x squared plus x minus 6 equals 0. One way to solve this equation, and you will be learning this in college algebra, if that's the direction you're going. One way to solve this equation is called solving graphically. If I put the equation in standard form, I've done that. Now, the next thing I do is I take the algebra part of the equation, which is x squared plus x minus 6, and I'm going to name that as a function. In college algebra, you will be taught how to type that function into your calculator and how to graph it. And when I do, this is what the graph looks like. Now what I want you to notice is the graph crosses the x-axis at 2. So one answer for x is x equals 2. The graph crosses the x-axis at negative 3. So another answer for x is x equals negative 3. And what's really happening here, when I say when is a function equal to 0, f of x is really another name for y. Where is y equal to 0? Y is always equal to 0 on the x-axis. So virtually when you're solving an equation, if you take the algebra part and turn it into a function, the answers to the equation are really the x-intercepts of the graph. It's a very nice connection to make in Math 1033 for those of you going on into the college algebra. If you're not going into the college algebra, it's probably not a major connection for you to make. Okay. One last comment is, if you solve this traditionally, this expression would factor as x plus 3 times x minus 2, and if you solved it the way we did previously, you would still get the same two answers. So there are two ways to solve this equation. One of them is called algebraically, which is what you're being taught in 1033, and a second way to solve it is what is called solving graphically by finding the x-intercepts of the graph and knowing they're the answers. And again, for those of you going into college algebra, this is a preview into your future. Okay, if I look at the, oops, too far, come back, and down a little bit more. If I look at the equation x cubed equals 16x, and I want to solve it, I first realize this is not a second degree equation, it's a third. A third degree equation is sometimes called a cubic. I still put it in standard form, descending power order equals 0. My first step in factoring is always to take out the GCF, that would be an x. In parens we have x squared minus 16. If I factor further, there's the x. I have an x plus 4, x minus 4, because that's the difference of squares. So look at how many cases I have. 1, 2, 3. If 3 factors multiply together to give me 0, I set up 3 cases. X equals 0, or x plus 4 equals 0, or x minus 4 equals 0. The first answer is 0, the second answer is negative 4, and the third answer is positive 4. Notice I have degree 3, called a cubic, and I have 3 answers. Answers are also sometimes called roots or solutions. Wow, that one does not want to stay for me. Let's get it back one more time. It's real sensitive here with this cursor. Excuse me. So we're looking at the equation. Oh, how frustrating. Okay, we're looking at the equation. Finally, x cubed plus 5x squared equals 9x plus 45. This is a cubic, i.e. degree 3. We're going to put it in standard form. So we descending power order equals 0. the 9x and the 45 virtually, I know, move over. So we have a negative 9x and a negative 45. Whenever I have 4 terms, I'm going to factor by grouping. So I pull an x squared out of the first grouping, leaving me with x plus 5. I pull a negative 9 out of the next grouping, leaving me with an x. This actually should be, I want you to make a correction in your notes. This right here should be an x plus 5. So make that correction. This is a plus. I can't do it on my computer, but you can do it on your paper. The x plus 5 comes out in front. The x squared minus 9 eventually breaks down to a plus 3 and a minus 3. When I set up my 3 cases and I solve, I get the answer negative 5, negative 3, and positive 3. So the only change I want you to make on your notes, this right here should be a plus. And think about why it should be. A negative times a positive gives me a negative. So make that change on your notes. Make it a plus. That's why the x plus 5 will come out of both of these. And that's again called factoring by grouping. Okay, our last problem that we're looking at talks about a baseball, and this is what's called a position function. It tells you how high the baseball is at any particular time. We're being asked to determine when the baseball is 100 feet in the air. So we are going to set the position function equal to 100. Okay? Height equals 100. Now what I'm going to do next, these 3 terms, I'm going to move over to the left-hand side to put it in standard form. I get 16t squared as a positive, I get negative 88t, and 100 minus 4 gives me 96. The next thing I notice, via factoring, I factor out an 8. In parens I have, that's my GCF. In parens I have 2t squared minus 11t plus 12. That further breaks down by using the FOIL method. You can see how important factoring is here. To 2t minus 3 and t minus 4. One clue I always teach my students. When the last sign of a trinomial is a plus, these 2 signs are the same as the middle. Now, the 8 is ignored because when does 8 equal 0? Never. So you only pay attention to the algebra parts. You set 2t minus 3 equal to 0, solve it, and that gives us 3 over 2, which is really 1.5 seconds. You set this second part equal to 0, and you get 4 seconds. Now, think of why there are 2 answers. When is the ball 100 feet high? Well, that's going to occur twice. Once on its way up, and once on its way down. So at 1.5 seconds, the ball was 100 feet, but that was on its way up. 4 seconds is the next time the ball was 100 feet high, but that was when it was on its way down. So on your course compass homework, when you go through all this work, pay attention to whether they're asking you for whether the ball's on its way, the time that the ball's on its way up, or the time the ball is on its way down. Okay? All right, this concludes 5.7.